thanks everyone for coming. Keep eating lunch, but I'm going to start for it so I have time to go through a whole bunch of material. We'll have time for Q&A and discussion, dialogue at the end. But so appreciate everyone coming here. It's awesome. I love this industry. I love what we do. And that's why I made the maybe foolish decision to spend a lot of time in October, November, December, and help from a number of the Liberty colleagues to produce this book. So there's a little bit of feedback in the microphone. I don't know if I should move further away or turn the volume down. And look, probably many of you have already read it or seen it, but I'm going to summarize just a few of the points that are in the Bettering Human Lives book, and then end talking about what's the greatest energy problem in the planet today, and most importantly, what are we doing about it, which is we have launched a foundation and would love your support, interest, and partnership in it. So real quick, you're going to go back to lunch or take a nap after this. Here's the quick summary. The last 1 to 2 centuries have just transformed the human condition like never before. I believe 2 things drove this: the rise of bottom-up social organization, human liberty, and this explosion in available energy from hydrocarbons. The shale revolution has turbocharged access to hydrocarbons. The volume of hydrocarbons and therefore push the price down. This is helping more people get these growing benefits from energy. However, at the same time where things in the hydrocarbon world are going so well, we're seeing meaningful rising opposition to hydrocarbons. I should qualify that. This is among the well-off people in the well-off countries. So it's a small minority of the global population, but of course this is the influential and powerful part of the global population. So the impacts are large. And so in writing this book, it's not full of policy prescriptions, it's not full of calls out or whatever. It's none of that. It's just trying to provide the data on how the world is energized, how that's transformed over time, how that might transform in the future, what it means for the human condition. And then a little bit of overview of energy poverty, of climate change. That's nominally the root of the opposition to our industry. And then climate economics. What do the experts say about the impacts of climate change going forward? And then again, I'll end talking about the foundation. But just a few pictures to show the transformation of hydrocarbons just cannot be overstated. That's the best land transportation we had 125 years ago. I could use the same picture from 2,000 years ago, about the same, and then boom. Now we can fly across the continent in a few hours. We can fly across the oceans. Food production is just dramatic. 80% of Americans were farmers 200 years ago, 80%. Today it's 1.7% of Americans work in food production, and we supply calories, 50% more calories per person than we did when 80% of us were farmers. So we're taller and maybe a little bigger around as well. We're also the largest agricultural exporter on the planet. And what transformed 80% to 1.7% dramatic increase in supply, really summarized in one word: hydrocarbons. Medicine. Look, I'm very partial to this. Without modern medicine, I would never have celebrated my 14th birthday party. So I'm pretty jazzed about modern medicine. And so if you look at doctors, or, we hear about classic doctors, Galen from classical times. Doctors have been around a long time, but the ability to meaningfully impact health outcomes, that's modern. And you see it in the Wright. Every material, machine, even the knowledge and ability to drive these innovations, one word drove that change: hydrocarbons. So the quick takeaways, and to a different non-energy audience, I don't lead with these takeaways. I don't want to push people away. I want to bring the data to show them here. But among this audience, these are at the end of writing a book, I just scribbled down what are the 10 big takeaways. And one is that energy is essential to life, and the world needs more of it. The modern world today is powered by and made of hydrocarbons. Hydrocarbons are essential to improving the health, well-being, and life opportunities of the 7 billion people that don't live the fully energized lives that we do. Hydrocarbons supply more than 80% of global energy, just as they did when I was born, and they'll probably supply roughly that percent when I die, which is going to be a long time from now. The American shale revolution, what you all work in, has just transformed global energy markets, energy security, and geopolitics. I mean, it is transformative. Global demand for oil, gas, and coal are all at record highs and rising. Modern alternatives, we hear the most about solar and wind, and that's where most of the money goes. They only work in one sector of energy, electricity, and they only provide a slice of a slice. Nuclear, I think, could be more impactful. I'm very passionately pro-nuclear. Probably won't talk about that today, but that's the other thing that could add to hydrocarbons as far as growing the global energy system going forward. But policies that make energy more expensive and unreliable, these are negative for people's lives, they're negative for national security, they're negative for the environment. Climate change is a global challenge. I'm going to talk a little bit about this. It's a real thing, but it's just far and away, it is not the world's greatest challenge, not even close. And I made a video and I wrote an editorial recently that hasn't come out with basically this point that net zero 2050 is just the wrong goal. And zero energy poverty, meaning basic energy access for everyone by 2050, that's the right goal. It's achievable and it'll make lives better. Net zero 2050 is not achievable, but the effort to achieve it is making life on Earth worse. All right. I talked about the transformation of the human condition. This is 1800 going forward. The big fat black line, that's life expectancy at birth. The bottom is where is the height is the amount of energy consumed, and the color is the source. So we were all renewable in 1800. The world was 100% renewable power. We had Shangri-La. We had some problems though, and it can be summarized by global life expectancy was just over 30 years, and 90% of the human population lived on the equivalent of less than $2 a day in today's money. Imagine your life if you had $2 every day. That's a different life. You can see the arrival of coal in gray, then oil, then natural gas, just exploding the available world energy. And then on top of that are what I call the derivative energy sources. They're energy sources only possible because of hydrocarbons, but because of hydrocarbons, we can build large hydroelectric dams, we can build nuclear power plants, we can build wind turbines and solar panels. We're able to build other energy systems, but they still don't contribute hugely to the energy system. But look at life expectancy. As energy consumption rises, so does life expectancy. Again, a more than doubling. You can see the little dip for World War I. You can see the big dip for World War II in global life expectancy. There's a third dip up there in the late 1950s. Free lunch for anyone who can call out. What drove that? What drove that dive down in global life expectancy? It was the rapid withdrawal of human liberty in one country. That's the Chinese Great Leap Forward, where Mao collectivized agriculture, took away farmers' ability to farm the lands they wanted, took away ownership and incentive rights, and they created by far and away the largest famine in human history. 80 million people died from youth all across the whole age spectrum. Unbelievable. Unbelievably awful. All right, we talk a lot about where energy comes from. I want to talk a little bit about where energy is used for. What do we do with energy? And in simple terms, about a little over a quarter of global energy is used for transportation, planes, trains, boats, automobiles. A little more than a quarter of energy is used for our homes, our businesses, our hotels, our golf courses, our arenas, our commercial use of energy. But what we don't hear enough about is not much less than 50% of all global energy is used for industry. And the simplest way to think of that is making stuff. And the reason you hear less about that is wealthy countries have exported the making of stuff. The United States has been the world's industrial powerhouse for 100 years, but yet today we consume 25 exajoules a year for industrial in the United States to make stuff, 25 exajoules. China consumes 70, 3 times as much energy. Energy-intensive manufacturing has just been pushed out of wealthy countries, and therefore it's out of sight, out of mind. That's our most important use of energy. Alternative to that, is we hear all the time about electricity. In fact, the press often confuses those two words. Portugal got 100% of their energy from wind and solar for an hour yesterday. That wasn't energy, that was electricity grid, and 20% of global energy is distributed in the form of electricity. So electricity is important, it's awesome and all that. It's 20% of global energy, not synonymous, energy and electricity. And of course, to have an electricity grid, all those machines, that transmission, all that, very material intensive. So what also represents 20% of global energy is we use 20% of global energy to produce 4 basic materials. And the greatest energy scholar of our time, Vaclav Smil, just really an awesome polymath. He termed these, and I use his term, the 4 pillars of the modern world. Just the 4 essential substances that make everything else we enjoy possible. Cement, steel, petrochemicals, and fertilizer. Over half of all cement and over half of all steel is made in China because they don't restrict industrial production. They use their energy resources to make stuff. And then they export it everywhere else. We produce a huge amount of petrochemicals in the United States, and because of the shale revolution, fertilizer production is also coming back to the United States. But if we really want to grow blue-collar jobs and income, and if you really cared about greenhouse gas emissions, you'd want to resource more steel and cement production in the United States as well. I think we will see a slow pendulum swing that direction. So on energy and geopolitics, this is just north of the center line here means you're a net energy exporter. Below that, you're a net energy importer. And this is last 34 years. So there's Russia. No surprise, Russia's a net energy exporter and has been for a long time. They've been a meaningfully rising energy exporter over the last 25 years. That's not necessarily surging energy production in Russia, although part of it's that. The other part is collapsing industrial production from within Russia. So they've shrunk their consumption of energy, grown their production of energy, and the biggest piece in their economy is energy exports. China, I first went to China in the early mid-1990s. China at that time produced as much energy as they consumed. They had the Daqing oil field, one of the biggest oil fields in the world. They're obviously a huge coal producers. They've never been that big of a natural gas producer, although they're working hard at it. Then China's industrial production and economy took off. Their energy production grew, but not nearly as much. And so they've become a massive, by far the world's biggest energy importer. Here in the United States, very different story, right? All of our lives growing up, the U.S. was big energy importer and growing energy importer. And all the presidents wanted to be energy independent. You know, we just kept sliding down that line. You know, and then something happened, right? Shale revolution, just an incredible elbow in that. We went from being the largest importer of natural gas on the planet, the largest importer of oil on the planet, to pretty quickly today, we've recently passed Russia as the largest natural gas net exporter on the planet and a net exporter of oil and oil products. Just incredible transformation of our geopolitical situation. The other region I'll talk about is Europe, right? Europe in all of our lifetimes, they've been big energy importers. They're meaningful energy producers as well, but they've had sort of the dual sins, I'd say, in the last 30 years of shrinking their energy production and shrinking their industrial base just as fast. So they consume less energy in Europe and they produce less energy. Now they consume less energy in Europe, but not if you count their imports of manufactured products that come from overseas. So they just push their industries out, they get made somewhere else, and then they buy them and import them back into their continent. But of course, they're very vulnerable for energy supplies. Let's zoom out and look at the United States. This is obviously a country we live in, and to me, sort of the paragon of a modern, wealthy country. So the length of these bars is how much energy comes from those sources. You can see we are completely dominated for our consumption, independent of production. The consumption of energy in the United States, 70% of the energy we consume is oil and natural gas. That's what powers the United States. Coal is a distant third largest energy source. Nuclear's fourth. Wood's number 5. Everybody got their Team Wood shirt on. You don't hear a lot about that. But behind wood is wind as the 6th greatest source of energy, hydro is 7th, and solar as 8th. Then the next thing I'm going to do is talk about the colors on this slide. Like that mustard color, that's electricity. Everyone talks a lot about electricity. Oh, we're going to convert everything over. Again, electricity globally and in the United States delivers about 20% of total energy. And natural gas, if you look at that second bar, largest supplier of electricity in the United States by a large margin. 43% of U.S. electricity came from electricity last year. I think that number will get to 50% in the next 5 to 10 years. But that's just one thing natural gas does, right? We also use natural gas for a non-trivial amount of transportation. We use natural gas as a huge source of heating and cooking. I am pro-food, and I am pro-staying warm in Colorado and Montana in the winter. Natural gas is a huge source of that. We also use natural gas heat for the industry we do have in this country, to make petrochemicals, to make steel, to make fertilizer. That's that red process heat. And we use the molecules from natural gas and natural gas liquids actually as raw materials to make materials. So if you look at natural gas stripe and you look at wind and solar, like they aren't going to replace that. They can make their mustard colored bar a little bit longer, but they're just not equivalent to what we get from oil and natural gas. That's how the U.S. is powered today. Now, one comment about energy and energy access. So there's about 1 billion people on the planet that live lives remotely recognizable to us. You know, they're in Western Europe and Japan. Some of them live in third world countries, but about 1 billion people live well-energized lives. They get around in motorized transport. They turn their lights on at their house. They use all sorts of materials made out of fancy exotic metals that we make. That's about 1 billion people. And those 1 billion people consume about 13 barrels of oil per person per day. 13 barrels a day. We're in the United States, so of course we're at 20, and the Canadians have to outdo us, and they're at 21 barrels a day per person. But just look at the average of that billion, 13 barrels of oil per person per year. The other 7 billion people in the world consume on average 3 barrels of oil per person per year. And of course, many countries, it's less than 1. But just think of the averages, 13 versus 3. What do you think those 7 billion people want? This, right? I've not met any of them that don't want to have lifestyles like us. Maybe I will someday, but I haven't yet. I haven't met one. I've traveled to 50 countries. And so to get that other 7 billion people just halfway to the lifestyle we have means we have to more than double global oil production. A little over 100 million barrels a day. We've got to get to well over 200 million barrels a day to get those other 7 billion people halfway to where we are. And I've heard my whole life since I started, peak oil, peak oil, peak oil. We hear it now, peak oil. I mean, it was BP and the IEA said we may have hit peak oil before COVID. To me, it's like, what are they thinking? Where does that idea even come from? It's just insane. And if you look at demand for oil, how many new barrels of oil is the world consuming in this year? The last decade's been the fastest growing demand for oil ever. But yet we're just about to hit peak. And those 7 billion people should just live the lives they live today. I struggle with that concept, both intellectually and morally. So we hear a lot about energy transition. So what I tried to do in this report, again, was just pull together the data. This, again, not opinions, not cheering, not booing, just data. In 2010, the world consumed about 500 exajoules of energy. Exajoule is short for boatload of energy, roughly equal to a quadrillion BTUs, but we're going metric. We consumed about 500 exajoules in 2010, a little more than 500. Today we consume a little less than 600 exajoules of energy. So progress, growth, people's lives are getting better. Where did that extra nearly 100 exajoules come from? What's the fastest growing energy source? When I'm in class, everyone knows it's solar or wind or some combination of the two. Well, it turns out the fastest growing energy source on the planet by far is natural gas. About 40% of all the growth in energy production over the last 12 years came from natural gas. Number 2 is oil, 24%. Coal is number 3 at 14%. Wind is number 4 at 9%. Solar is at 7%. Disappointingly, nuclear didn't grow at all. We decommissioned as much nuclear in the wealthy countries as got built in the developing nations. So basically a non-contributor. Hydro contributed a non-significant, a non-trivial component, but there's not massive room left for hydro to grow. There's some other energy sources. Traditional biomass, I cheer this one and we'll end about that. It actually, for the first time in history, over the last 10 or 12 years, has declined as a total amount of energy supplied. That's progress, actually. That's propane replacing wood. We need a lot more of that, but hey, that wheel's starting to turn. So that's to get us to about 600 exajoules. If you just economically project the way trends are going now and you look out to 2050, in round numbers, maybe we need 800 exajoules of energy then. So that's 200 more exajoules in the next 25 years. Where are they going to come from? In the last 12 years, 76% came from hydrocarbons. That almost everything. To me, now we need we got to add twice as much incremental energy in the next 25 years. I hope it's not all hydrocarbons. My best bet is nuclear has the most probability to add a meaningful amount of energy without hurting the global energy system. But that's not moving today, and that's a tough stone to roll, but I think we gotta push for that. Let's just look at the US. So this is not consumption, this is production. So there's imports and exports. This is just what the US produces over that same time period. Just what's changed over the last 12 years. Well, we produce a lot less coal, but coal's not shrinking, as I showed in that last slide. Coal's still growing, and it's a huge energy source. But in the US, coal is being outcompeted by abundant, low-cost natural gas with infrastructure, pipeline infrastructure. So we've had surging production of crude and natural gas liquids, surging production of natural gas. Again, nuclear in our country, just like the planet, roughly flat. If you squint, you can see that big growth in wind and solar over there on the right. Like that's about $500 billion. So we do have growing wind and solar energy, but it's just on a much different scale. So let's look at new energies. So like a technology that wasn't around, that arrived on the scene, how fast did it add energy to the global energy system? Here's nuclear in the United States. We started at any scale to build nuclear power plants and started to contribute to our energy system in 1970. It grew really good for a couple decades. We lost public support and it's basically plateaued. That's nuclear in its first 50 years. Here's wind and solar in the United States. A lot of money, huge amount of land. It is growing rapidly. Let's look at a global scale. Nuclear is a similar trajectory on a global scale, but of course, much more. It's all the countries of the world, not just the US. Wind and solar and the same thing. Huge investments in it. It's growing rapidly. But think of the numbers I said. 600 exajoules global energy consumption, wind and solar, 12, right? A lot of engineers in the room, 2% of global energy. $4 to $5 trillion, 20 years, mandates, inflated electricity prices, all of that, and it's got to 2% of global energy. Now you often hear, if you look at stuff or you dig into the IEA data, it says 5%, 4 or 5%. Chris's data must be wrong. But the real answer is, this is the correct data, and the other data you see in all the other energy agendas is frankly just wrong. Because what do? They take the energy produced by wind and solar, they calculate it all, same data I use here, and then they multiply it by 2.5. If I want to heat my home with electricity or turn on my lights, I don't get 2.5 times more energy. I get the energy that's delivered. So I talk a little bit about that. The EIA has since issued a note that they're rethinking how they report wind and solar. But I'm going to stick with the real numbers. So here's the shale revolution. And this is just the United States. It's not including Canada. And think of, and it's got the COVID slowdown in there. If I added the 23 data with huge growth, this number gets even larger. If you add in the production in 2023, just production from U.S. shale is 10% of global energy and about 60% of total energy in the United States. That's something no one heard of 20 years ago. That's private capital, private investment, and just an enormous amount of scale of additional energy in the world. The biggest source by far of that growing nearly 100 exajoules over the last 12 years came from one thing, what you do every day. What does it mean for the U.S.? This is economics. This is just balance of trade, our exports minus our imports of energy. So no surprise, 15, 20 years ago, U.S. was a big net importer of energy. That scale left, that's hundreds of billions of dollars per year. So we imported, say, $300 or $400 billion a year energy deficit. We imported more than we exported. And then if you go to the most recent data, we're about $100 billion a year net exporter of energy. So just $300 to $400 billion swing in economic well-being in our country just from shale revolution. And just in the energy sector, not the trickle-down benefits of consumer benefits and businesses, manufacturing benefits, just balance of trade. Well, I remember when I was a kid reading Paul Ehrlich, and I was a mountain climber, still am a mountain climber. I wanted to be in the outdoors. I was an environmentalist. I was reading what everyone wrote, and Paul Ehrlich had his famous equation that your impact on the planet was equal to your country's impact was your population times your affluence, how wealthy you were, what your income was. And then he did put in the times the technology factor, but he didn't talk about that very much. So here we are in the U.S. since 1970. Our population's grown about 60%. Our income per person's grown 150%. So a lot more people, a lot wealthier, therefore massively worse impact on the environment, right? Not so much. The green line, this starts from 1970 because that's when the EPA passed the Clean Air Act, naming 6 criteria pollutants, the ones that were the greatest threat to human health. And they've been tracked very well since then. On a per capita basis, the emissions of those pollutants has dropped 86%. That's the technology piece. But as I'll show in some more slides too, the more oil and gas you produce, the more modern energy you produce, the better health, the cleaner environment, the cleaner air you get. We didn't get reductions in CO2 emissions until the arrival of the shale revolution. We got cleaner air, which was awesome. We got continued cleaner air and reduction in CO2 emissions per capita with the arrival of shale gas. Now the lowest on a per person basis in a year since I was born. All right, but we hear a lot about an energy transition. If they're not producing meaningful energy, why do we hear it so much? And I think here's the short answer why. That left scale, I don't know if I'm blocking it, that left scale is CapEx in billions of dollars. So green is oil and gas CapEx, peaking at over $1.2 trillion a year for a few years. We've been below $1 trillion a year for a long time, but yet production's at record highs. One word for that, efficiency, technology, but they call them carbon-free. There is no such thing. So lower carbon intensity energy sources, which is all the others. So nuclear, modern biofuels, hydro, wind, solar, all that. What has CapEx done for that? 5 years ago, it did cross. It is greater today. More money on an annual basis is spent on low carbon energy sources than is spent on oil and gas. Coal is down here at the bottom, ambling along, maybe $200 billion a year globally on CapEx for that. So the money has transitioned where it goes quite a bit. But what's the money brought us? So green is the percent of global energy from oil and gas. The white or gray or whatever it is, that's coal. And the bottom is the percent of global energy that comes from these low carbon sources. So look, we've spent, if I integrate the whole thing over there, nearly $10 trillion, and we've gone from about 13% of global energy to about 14%. So that's not nothing, but I think it's hard to call that a transition in any real sense of the word. Why? And real quick is because different energy systems have different strengths and weaknesses, and they all have strengths and they all have weaknesses. There's no clean energy sources. There's no dirty energy sources. They all have different trade-off packages. But I'll give you 3 reasons why most of the money we spend hasn't meaningfully impacted the global energy system. The first is energy density from a land perspective. For each acre dedicated to oil and gas production, you produce enough energy to power about 180 homes. For each acre dedicated to solar production, you get the energy for a little more than 1 home. And for each acre dedicated to wind energy production, you get enough energy for a fraction of a home. 1,000 times more land to produce the same amount of energy from wind than versus wind or solar. Land is finite. Land use conflicts are growing, not shrinking. The other thing is materials. To drill our oil and gas wells, that's a lot of steel. That's a lot of cement. We got to lay pipelines and processing plants. That's a lot of energy-intensive materials we use to build our systems. In fact, we use almost 1,000 tons of mostly cement and steel to produce a terawatt hour of energy. The problem is, for wind and solar, it's more than 10 times that much. Steel and cement are expensive, they're heavy, and they're energy intensive. So if you're going to take 100 to 1,000 times as much land and more than 10 times as much material intensity, it's harder to get to scale. And I think the bigger one, look, I've worked on solar energy in graduate school. I still think solar is going to play a role in the long run. I don't, my bet is wind is not. But the third problem is just intermittency. You know, when your kid is sick and you take your kid to the hospital, you know, that scanning machine, it's got to work right now. Not when the sun comes up, not when the winds pick up. It's going to work now, right? Energy is only worthwhile if we have it now. And when we don't want it anymore, it stops. That's what an energy system does. So think of an Uber. Would you pay the same amount for an Uber if you weren't sure when it was going to arrive and where it was going to drop you off, right? Just if they both drove you 10 miles, they're just not equal value, right? They're just fundamentally different things. So more land, massively more materials, and you don't know when you're going to get it. That's not a value proposition that's ever going to scale. All right, health. Well, but oil and gas is evil, and it's polluting the air, and it's hurting human health and all that. So let's just look at the quick data on that. Round numbers. Again, engineers in the room, 100 million people die every year, right? 8 billion people, life expectancy a little less than 80 years, 100 million people die every year. About 40 million of those die from maybe things we have some control over. 3/4 of those are lifestyle, obesity being the biggest one, eating habits, obesity, smoking, alcohol, drug use, things we do in our lifestyles that shorten our lives. That's about 30 million deaths of those 100 million deaths. 10 million of those deaths, the biggest factor contributing to a premature death is environmental impacts, you know, the conditions we live in. The biggest piece of that environmental impact by far is air pollution, indoor and outdoor air pollution, about 10 million deaths a year. So if you're in Africa and your biggest energy source, more than half or about almost half of their total energy consumption comes from burning wood. It's only number 5 in the US, but it's number 1 in Africa. It's deadly. Wood is very smoky, dusty. It's not good for air quality. Africa has 10 times higher risk of death from air pollution than we do in the United States. The globe as a whole, look at world right there, coal, oil, gas, wood still a big piece. With that energy system, that's 5 times deadlier than the United States. But when you get over to where your energy system is dominated by oil and natural gas, they're just massively better for air quality. Wood is by far the worst. Coal is much better than wood, but not nearly as good as oil and natural gas. So when you go over to our energy system, you just have a dramatically lower risk of health and premature death from air pollution. Now this is same data plotted a little bit differently. This x-axis is your risk. It's deaths per 100,000 people from air pollution. And the right axis is how many barrels per day does your country consume of oil. So just taking one piece of that energy system. And this is, again, that oil is unhealthy. Well, the countries that consume the least oil have far higher deaths. And so that's just basically a plot of all that data. US and Canada over there, a lot of oil per day, but we live in very clean air. Not zero impacts from pollution, indoor and outdoor, but dramatically reduced. Okay, well, that's the short term. What about the long term, climate change? Let me run through some climate data. I think it's important that we understand the basics of this. So this is this observatory in Mauna Loa where we measure atmospheric concentration of carbon dioxide in the atmosphere in parts per million. So we think it was about 280 before industrial activity. When we started measuring it, it was 310 or 315. And it's risen up today to about 415 parts per million, or 0.04%. So still a trace gas, but a growing concentration trace gas. I always think when you plot something, first plot the whole data set, don't cherry pick data, and then put it in context. So I put two contexts there for CO2 concentration. The upper line is the doubling of CO2 concentration. The climate models and debates about climate sensitivity, they're all about how much net warming would we get if we doubled CO2 concentration. From this infrared radiation absorption, there's feedback effects there, which is why there's a big debate about what the climate sensitivity is. But all those numbers are based around a doubling of CO2. We've probably hit that by the end of this century. It's not for sure, actually, though, because the more CO2 that's in the atmosphere, the more that's getting absorbed by the planet. I'll come back to that. But in any case, it's rising, and safe to say it's going to keep rising for a long time. The other thing I put on there is 150 parts per million. Below that concentration, photosynthesis ceases. So if instead of raising ambient atmospheric concentration of CO2 by 50%, which we have done mainly from our industry, if we had lowered it by 50%, photosynthesis would cease, right? Plants would not grow. Corn, wheat, trees, whatever. That would be a crisis. I think we could even call it a climate crisis. So we just live in a time that in the Earth's history is relatively cold and relatively low in atmospheric CO2 concentration. We evolved in these times, so they're not evil, they're not bad, it works. But it's going down a lot would not be good. Now, I don't think there's a great risk of it going down, but it's been slowly going down over the last 70, 80 million years. We have changed that trend. What's the biggest, most visible impact of climate change? This is NASA satellite data, a thing called Leaf Area Index. And it's basically how green is the planet. So over the last 40 years, the world is getting meaningfully greener. You can see some deforestation in the Amazon there, but across the planet as a whole. And why? Well, there's 50% more plant food in the atmosphere. And the planet's a little bit warmer. And if a planet's a little bit warmer, it means a little more water evaporation, it means the planet's a little bit wetter. So if you make something wetter and more plant food in the atmosphere, you get more plant growth. This is hundreds of billions of dollars a year benefit in agricultural crop productivity because of this change. You don't hear about that a lot. But climate change has negatives and minuses, as everything else does in life. But when I was a kid, the worry was the Sahara Desert was growing and desertification was going to make the planet an unlivable place. That's reversing now. I'm not sure it was actually happening then, but that was one of the scare tactics. But now the Sahel below the Sahara is slowly greening. Temperatures are rising. There's surface temperature records for maybe 140 years. They're not bad, but there's a lot of limitations with them. So I stick here with just the most highest quality data, which is atmospheric satellite data from 1979. So we have 45 years of this data. And this is monthly data. You can see a huge spike up. That's an El Nino. We're in the middle of a big El Nino right now that's dying. Now we'll see global temperature drop a lot as we go into a La Nina. That's just exchange of heat between the atmosphere and the oceans. They're just going back and forth. So you can ignore those fluctuations. If you look at the slope of that line, and it hasn't changed wildly, the world's warming right now at about 0.14 degrees C per decade. So between now and the end of this century, we'll probably warm by about another degree C. We've warmed a little more than 1 degree C so far. And again, part of this may be natural. Obviously, the warming of the planet started well before industrial use of hydrocarbons, but I'm a firm believer in the math and physics supported that increasing CO2 and methane in the atmosphere absorbs infrared radiation and either drives warming or adds to existing warming. It is a warming impact, without a doubt. Sea level rise. Satellite data, we have tide gauge data going back 300 some years, but here's the highest quality data set we have from satellites. And 2 points from this data. One is sea levels over this 30 plus years of data, sea levels rising about 1.3 inches per decade. The rate of sea level rise has continued at a roughly similar level through the whole data set. So we're not seeing an accelerating rate of sea level rise, but sea levels are rising, and they are rising faster this century than they did last century. Last century, the sea level rose globally about 8 to 9 inches. This century, maybe a foot, 13 inches, 14 inches, something like that. Last century was the greatest century of human progress ever. With 9 inches of sea level rise, is 13 inches of sea level rise going to cause that to come crashing down? Actually, in reality, it's not likely a meaningful factor in world well-being. Polar bears, you got to pull at the heartstrings. I've never seen a polar bear in person yet, but it's on my list. I don't want to be in the same ice floe, but nearby. But when I was born, there was about 12,000 polar bears. Nobody knows exactly, but that was sort of the guess of the U.S. Fish and Wildlife Service. Today, there's more than 25,000 polar bears. And that's not climate change that's caused this more than doubling and growing polar bear population. It's just ending hunting of polar bears that has caused that population to grow. Polar bears also have been around for a long time. We're in this cycle of, we're technically in an ice age right now. We're in the interglacial period of an ice age, which is what human civilization evolved in. But we've had multiple ice cycles and interglacial warm periods. The last one, the Eemian warming, was meaningfully warmer than it is today. It does not look like there was any summer ice in the Arctic during that period. And polar bears sailed through that no problem. So I'm not worried about them disappearing. And in fact, their population is growing. Hurricanes. The other thing we hear a lot, when I was 30 years ago, was warming. Now they still talk about hot days, but that didn't really catch fire, because if you're warming 0.14 degrees per decade, I could warm this room a degree centigrade. I could give you 80 degrees of warming in like 30 minutes, and most of you would not notice it. But weather is effective. Like, everyone is terrified of hurricanes and tornadoes and serious weather. So we hear a lot about extreme weather. Here's the data on global tropical cyclone landfalls, hurricanes that hit land. That data, again, I always plot the entire data set. This is not cherry picked. That's all the data we have globally. There's been a slight increase in small hurricanes and a small decrease in big hurricanes. If I do total cyclonic energy, sort of summing up all of them, hurricanes are flat through the whole data set. They have times of more active, times of less active, but there's no trend in them. That Intergovernmental Panel on Climate Change, same data, same conclusion. Not the media, not the activists, but that's the actual data. Here is hurricanes that hit landfall in the United States. So since it's a smaller geography in the U.S., we got a long data set, 125 years, a slight decline. But another way to call that is just flat. There's more and more storms. Again, the honest answer is there just isn't. The one extreme weather thing that actually has a little bit of a trend is tornadoes. Tornadoes have been on a decline. We don't really know why. I've got a theory, probably wrong. But in any case, tornadoes are scary and nasty, and they kill people and they destroy homes, as do hurricanes. All these things are deadly serious things. But fortunately, they're not increasing. Drought. We hear a lot about drought because people picture it as hotter, it must be drier. No, it's the opposite. If the world gets hotter, it means more water evaporates, which means there's more rainfall. When it was cold during the last glacial period, we came out of the Ice Age, the glaciation about 20,000 years ago, that's when the Sahara Desert got created. When it's really cold for a long time, it becomes very dry and very windy. So that's global area. That's over a century of data. Drought is on a gradual decline, just as we would expect. Flood damage as a percent of GDP in the U.S. Flood damage is trickier because it's not just rains. It's how do you manage the flood? What are the structures you've got? But it's been on an 80-year decline. Global weather disaster losses. This is insurance companies and climatologists looking carefully at that because there's a lot of talks about insurance markets and all that. But total global disasters as a percent of economy have been shrinking. It shrunk about 20% over the last 35 years. Billion-dollar storms is the term they use now. More billion-dollar storms. Well, there's more billion-dollar storms because we're getting richer, and there's a thing called inflation. But if you correct it, 2% of economy, we're actually going the other way. I don't think this is decline in extreme weather. We're richer, and we're building smarter and more resilient buildings. So it's slowly declining. Wildfires, I can go on about this one forever. Turns out in the West where I live, it's a semi-arid region, and wildfire is just a huge part of the ecosystem. We used to burn way more acres than burn today just naturally. And then there was a huge fire called the Big Burn in 1910. It killed killed like 80 people. It burned millions of acres in a few days. It scared the crap out of everyone. And they decided, we're going to do something about forest fires. Remember the Smokey the Bear campaign a couple decades later? And we did indeed, through fire towers, through forest control, we plummeted global wildfires. Then we got an environmental movement, and you can't touch stuff and you can't do things. And we sort of put an end to managing forest. You can't cut anything, you can't touch it. We stopped doing forest control. We reduced logging. And so no surprise, it's been predicted for a while, we're going to see an increase in wildfire. There's 30% more wood mass per acre in the western forest now than there was 50 years ago. We just stopped forest management, so there's denser, more undergrowth. There are actually less natural forests today, and they are riskier to wildfires, but nothing like the natural rate of wildfire burn. Most important climate data by far, deaths from extreme weather. 100 years ago, over 500,000 people every year died from extreme weather. Think about that. That's more than 10 times as much as today, and we had 2 billion people on the planet then compared to 8 billion today. So the risk of death for each person from extreme weather today is 98% more than 98% lower today than it was 100 years ago. And it's been declining all throughout that. And more than 20% of children report nightmares of climate change because they're afraid of the risk to them of this unvarnished climate that's going to be scary and destructive. So when it's the safest it's ever been from extreme weather, we have the highest ever anxiety. Climate economics. This is deep, nerdy stuff, but there's a lot of people who are economists who study what are the impacts so far of climate change, what might they be in the future. Now, do we know what the climate's going to be 100 years from now, or the economy? I mean, yeah, this field is a little bit of a stretch for sure, but it's a serious thing. It should be done. William Nordhaus, a Yale economist, won the Nobel Prize in 2018 for his work in climate economics. I'm going to show a little bit of that in a second. So in any case, but the people, and think if you're an economist and you don't think climate change is that important, well, you might not work on climate change. It's a little self-selecting to people more interested, maybe more concerned about it. So I don't think the data is skewed down, but look at the effort. We're probably going to have about 2 degrees C warming from pre-industrial times at the end of this century. We're a little more than 1 degree right now. 2 degrees C warming. Some people say it's a slight positive. Some people say it's a negative. The most extreme one down there says it would reduce per capita income by 2%. In the economic models used for this, at the end of this century, per capita income is up 400%. So the question is, with no mitigation of climate change and you get that 2% reduction, your great-great-grandchildren might be 392% richer than you instead of 400% richer than you. I mean, that's a bummer, but that's not a crisis. I don't think that's a climate crisis. And I think compared to other global problems, it's just, we're going to make electricity expensive. We're going to export jobs. Europe had 68,000 excess deaths, not the winter we just went through, the winter before, a warm winter. And always more people die in the winter than die in the summer. 8 times more people globally die of the cold than die of the heat. The cold is the killer. They had 68,000 excess deaths compared to a normal winter in a warm winter because heating prices were high. Like, to me, to lose 68,000 people because of bad energy policy, I lose more sleep over that than my kids being only 392% richer than me. They're going to, not my kids, my great-great-grandchildren. I think they're going to be okay. So here's another work of economists that gather every year at this thing called the Copenhagen Consensus and say, if we could solve these problems, how much better would the world be off? If we had nutrition and we didn't have so many people starving or malnourished, how much wealthier would the whole world be? Most people aren't starving, but if we could get rid of all those people that are malnourished and fix that problem, the world as a whole would be that much wealthier. If we could solve this problem, indoor air pollution, outdoor air pollution. Here's these other challenges projected out to 2040. Here's climate change. I'm trying to put Nordhaus's data on there. Of course, if I really put his data on here, it would just be on the origin. You wouldn't see it. So I had to cheat, amplify it a little bit, and turn it up so you could actually see it. But in his impact, in sort of a worst case of warming, where we do almost nothing about it, it's still less than a 1% impact by the year 2040 compared to issues we can do something about with massively larger impacts. So with that, and I'll give all these slides to everyone. Everyone can have all the slides. I'm going to end with this thing on climate impacts. Here's my takeaway from this. We need to stop highlighting our Scope 1 or Scope 2 greenhouse gas emissions reductions in page 1 or 2 of our annual reports or sustainability reports. I know people tell me, but investors want that data. Put that data on page 42, you know? You can put it wherever you want it. But when we lead with it, we're telling everyone that this is one of the most important challenges of our industry. This is the most important things we do. To me, we are contributing to climate alarmism by doing that. I hear it all the time. Kids tell me, well, even the oil companies think climate change is the biggest problem. They talk about it all the time. Obviously, those guys are the ones who are going to die. Their industry is going to be killed, but yet they talk about it all the time. To me, we are misinforming the public by doing that. We think we're appeasing people that don't like us. I don't actually think, in my experience, they don't care about Scope 1 or Scope 2 emissions. I'm okay with doing them. We always want to get better. We want to reduce our pollutants. We want to reduce our truck traffic. We want to be safer. Oh, look, we're an industry about doing better and better and better. I want us to highlight the things we're doing better. Reducing greenhouse gas emissions is one of them. I just think we need to put it in appropriate context. The only specific, quantitative number for impact I put up front in the Bettering Human Lives report is that over 100 million people get their clean cooking fuel from wells fracked by Liberty. That, to me, that's a big deal. That's a big deal. And everyone in this room, the amount you're changing of people's lives, making their lives better, making their lives longer and healthier, these are just awesome. And we got to talk about those. We could also talk about, we're reducing air pollution, reducing truck traffic. We should talk about reducing the negatives of our industry too. But we got to let people don't know what the world would be like without our products. And if we don't tell them, believe me, no one else is telling them. 2 quick case studies for countries that have decided we're going to take climate change, at least politically, as the most important issue. And darn it, we're going to show how a rich country can change this. We can solve climate change. Germany has spent $500 billion to $1 trillion, depends on you count it, in an economy an eighth the size of the U.S. Scaling it up, this is many trillions here. What have they done? They've more than doubled their electricity prices, more than triple electricity prices in the United States. Their industry, they're an industrial powerhouse. Their industry has been shrinking. New industrial investment's been plummeting. High energy prices are a big political issue in Germany right now. And with all of that, they've dropped their amount of primary energy from hydrocarbons from 80% to 74%. And if you impoverish your people, export your industry, make people angry so your far-right populist party is on the rise, and that's the downsides. And the upside is you went from 80 to 74%. I'm not sure that's a success story. The United Kingdom, and the EU I won't even talk about, but the United Kingdom, I'll just end with this punchline. The United Kingdom is proud. I've been there a number of times, and they'll tell you they've reduced their greenhouse gas emissions on a percent basis more than anyone else, and they have, by about 40%. Now, there's some lying in that because they burn wood at the former Drax coal power plant, and they call that carbon neutral, and that's complete rubbish. But let's grant the lie. Let's grant that accounting. They've reduced their greenhouse gas emissions by their accounting by 40%. They've reduced their total energy consumption by 28%. So the vast majority of their greenhouse gas reductions came from one thing. They just consume less energy. And what does that mean? It means, that the birthplace of the Industrial Revolution has exported almost all its energy-intensive manufacturing industry from the Midlands of England that was powered mostly by natural gas and by coal, but natural gas is the biggest source. Now it's all made in Asia, powered by coal, loaded on diesel power ships, and sent back. That isn't even greenhouse gas emissions reductions. That's just exporting them and actually growing them. And then the other mechanism for reducing greenhouse gas emissions is if you make something really expensive, guess what? People will buy less of it. If movie tickets were $80, a lot less people would be going to the movies. And so they have successfully got their low-income consumers to heat their houses to lower temperatures in the winter and cool them to higher temperatures in the summer. And again, measured in the high single-digit to low double-digit thousands of excess deaths by impoverishing their citizens so they can afford less energy. Like, I don't view that case study as a success either. Energy is illuminating. When I ask kids which Korea do you want to live in, just from the picture at night, haven't gotten any votes for the North yet, but again, I probably will. Energy access is green. This is the border of Haiti and the Dominican Republic. Haiti's biggest energy source by far is oil. Dominican Republic's biggest energy source is oil. But Haiti still has a fair number of people still living on just traditional energy, which means they've deforested their country. And Dominican Republic's wealthy enough that almost everyone has hydrocarbons for their fuels, for heating, for cooking and all that. They got a nice rainforest and a great tourist economy. I've already sort of hit this point. The more energy you consume per capita on that x-axis, the higher the Human Development Index, which is life expectancy at birth, per capita income, and average years of education. More energy, better lives. I talked about up front, 1 billion people live like this. Maybe another couple billion people have motorized transport, but it's a scooter. They don't have running water in their house, but they get water from a pump. They've got clean cooking fuels. You know, that bottom 4 billion, half of them are cooking with clean cooking fuel stoves. Half are cooking with wood and dung. The poorest billion don't even have bicycles for transportation. Like, our biggest challenge is more energy and cleaner energy. Let's get rid of wood. We can replace wood with propane. More energy consumed, the lower child mortality you have. The places of low energy consumption are the places of high child mortality. So I made a quick list. What are the biggest solvable problems in the planet? Malnutrition, you saw those in the Economist things, basic health care, indoor air pollution, outdoor air pollution, universal education, rule of law and property rights, human liberty. These are the things that are going to change the game and how people live their lives. We've decided to focus on one of them, right there, indoor air pollution. Some clean cooking fuels. The people that have, if you got a pipeline at your house, you've got methane, you got natural gas in your stove. You live in a farm or a rural area. My house in Montana, I'm not on the grid. My heating and cooking is propane. 22 years ago, 3 billion people didn't have propane to cook on. They were cooking on wood or dung. We've had huge progress, and I'll show us in a second why we've had that huge progress. When we still have 2.2 billion people and 3 million deaths. 3 million deaths. Here's the great thing we've done already that our industry has done. This is propane exports by country, 2010, 2012, 2-year period cycles, the height of that bar. If you look back in 2010, the United States was the 8th largest exporter of propane. Today, because of the shale revolution, we export more propane than number 2 through number 8 combined. We've flooded the world with propane. A lot of it's used in petrochemicals, but of the exports, about half of it is used for heating and cooking. You know, it is game-changing. It's the biggest source of heating and cooking on the planet. But again, we still have 2.2 billion people that don't have it yet. And that's what the Bettering Human Life Foundation is all about. You live in a smoke-filled room. Women spend over an hour a day gathering wood, another hour plus a day gathering water. They got to wake up early to build a fire, stoke it. Women get up at 4 o'clock in the morning to try to get breakfast, something to eat at 6:30. For kids, they spend their days over, and this is brick. This is a nice house that's got more room. You live I go in these thatch huts. That entire thing is smoke. It's hard to see through it. Every hour they're indoor, they're breathing smoke and particulate matter. You transform life condition for women and children and that family. To them, in the short run, it's just liberating. I'm not going out and scrounging for wood or paying $1 a day to buy a charcoal bundle. Pound of charcoal takes 6 to 8 pounds of wood. Huge deforestation problem. Because as people graduate from scrounging for wood, they're buying charcoal. But the real endpoint is to get to a propane stove. Our executive director of the foundation is Ann. Raise your hand, Ann. So Ann actually heads back to Africa on Sunday. and spent 30 years in public health, international public health. First in the former Soviet states, because she speaks Russian and is in public health. She lived in Indonesia. She speaks Bahasan. She speaks French. She speaks English. I'm missing a few. Tagalog, the Filipino language. But in any case, in this problem, she spent the last 6 or 7 years in Africa working on maternal and newborn child health care. But you try to get someone in for health care, you deliver a baby, and then you bring them home, to where they're going to live. And you live in a smoke-filled hut, the infant strapped on the back, and you got to go scrounge for wood. And I think after doing that for years, she realized, man, it's great what I'm trying to do, but I'm not working on the biggest problem. The biggest problem is changing the basic living conditions, heating and cooking fuel system for these families. So she has quit her 30 years at Johns Hopkins University at Chicago as the executive director of the Bettering Human Lives Foundation. We're starting in Kenya and Ghana. And our model, it's got to be sustainable. It's got to be something that's going to go on. So what we're doing is there's already entrepreneurs that are delivering on bikes or whatever, propane canisters and cook stoves, and then refilling those canisters. There's an industry. 15% of Africans have clean cooking fuel. 85% of it want it. So those existing businesses, we're making very low interest loans so they can grow their businesses, or investments in technology so that costing in the suburbs of Accra in Ghana costs about $1 a day for a charcoal. You've moved into the suburbs now, you're working in some kind of wage economy. You're not gathering wood anymore. You're buying $1 a day for charcoal. Propane costs $1 a day. Right now, they're equal in cost. Charcoal is going to go up as deforestation makes it harder to find new wood supplies. Propane's cost is going to go down because the cost of propane, in a village in Africa, it's like 8 times what it is here in the United States. But as that infrastructure goes and we can get more propane over there, it'll be a big cost advantage. But getting people over that hump to get a stove, to have that working capital, to be able to either buy or rent a stove, and to help those little businesses that already have 3,000 canisters, they could have a business 10 times as big. But if you're a small entrepreneur in Africa, for most everyone, there's no access to capital. But if you're lucky and you check some right boxes and you can get a loan, it's 30 to 40% interest rate. Could we have built our businesses at 30 to 40% cost of capital? No. So what we're doing is bringing 4% cost of capital. We're doing it as loans for a reason, because we only want to back businesses that are already successful, that can grow their business and therefore give more people access to clean cooking fuel. And then, so I want them to think hard about that investment. If you're taking out a loan, you better make sure everyone will take a grant, but you take a loan if you think you're going to grow the value of your business more than that, and you're going to generate the cash flow to pay that loan back. And then we're going to reinvest that loan in all the other businesses in that area. So we believe for tens of dollars a person, we can change the trajectory of those families. When you go from abject poverty to our lifestyle today, that's a long road, but the biggest step on that road is transitioning to clean cooking fuel. Thank you for your time. Ann is here. Paul Vitek and Audrey are here, also involved with our foundation. If you want to come up or talk to us one-on-one, or I'll take, obviously, questions from the stage if people have time. I know everyone's got to run out pretty quick. So I went through a ton of data, but I think to lead to the right conclusion, it's just to look at not my opinions or my views, but what's actually happening with the global energy system. What do we actually know about climate change? We don't know the future, but we know the data today. We know maybe the range of predictions for the future, and they just don't align with the narrative. But thank you all. To Bettering Human Lives. Questions? Yes.
So Chris, when you in this presentation to our leaders, to our political leaders, right?
Chris, when you give this presentation to our political leaders, what do they say? What's their feedback? Are we making any progress, I guess?
I don't know. I would say the vast majority of them just have no idea. They have no idea of these facts, but I would say almost everyone is moved by that. We had a very progressive politician in Colorado who was in a room when I gave this thing, and she was just like, oh my God, I never connected our energy policy with poverty, never. She was from Africa. She's from Africa. But so I think most people are just not aware, but presented with it. I think it's pretty compelling. Even students at universities, they've only heard one thing, the greatest threat to people's lives is climate change. If they see a little data and they hear about some other challenges, I think people are very movable on this energy dialogue. Now, media and activists, there's exceptions to that, but what's the Scott Tinker term? The radical middle, of 60, 70% in the middle are just massively movable. They just don't, you've only heard one thing, you believe that. So I think we absolutely, and I think we also have to me, the biggest driver is just, we're going to change hundreds of thousands of lives in the next few years and millions of lives, 3 to 10 years out. That's certainly what drives me. But I think doing it is also going to help shine a light on, oh my God, the world has bigger problems, and we can do something about that. All of us could do. A VC firm in Silicon Valley, when I talked to them about it, they're like, we want to be part of that foundation. We're training entrepreneurs in Africa. We should be training clean cooking fuel entrepreneurs. We want to donate to that foundation. People just don't know, right? Nobody talks about it. 3 million people every year die from lack of access to clean cooking fuels. That's only a little less than the annual death rate from COVID. And we shut down the world because that was rich people in rich countries that were dying of COVID. This is poor people in poor countries. And so you just don't hear about it. Everyone, thank you so much for coming today. We'll be around, but everyone else, run back to your business. I appreciate you dedicating a lot of time today to come hear this. We'll do more of these talks. And again, the talk series is Liberty and Energy. Not Liberty Energy, the company name, but it's just stories on growing liberty and opportunity for people, stories on energy or interplays between the two. We've been doing a quarterly one in Denver. We should try to start doing it, eventually get to a quarterly one down in Houston. This is the first time I've ever spoken at a Liberty and Energy breakfast too. Normally the speakers are really good. But it is a great series. But again, thank you for working in this industry. You're making just an enormous impact on the world and people's lives. And God bless you for doing that.